Imagine launching a massive software update to, millions of users.
Yeah.
And if anything breaks, it costs thousands of dollars a second.
Terrifying, right? Oh, absolutely terrifying.
Yeah, well, welcome to this custom deep dive. Today, we are unpacking a specific set of practice questions for the Linux 701-200 exam.
And since the exact mechanics really matter in cloud architecture, we need to make sure we don't rush this.
Exactly. We are going to take a deliberate, measured, and slightly slower professional pace for the entire deep dive. Okay, let's unpack this. Question 1. Which strategy involves a software deployment technique where two identical hardware environments are maintained, with one serving production traffic and the other receiving the new release?
The correct answer is A. It's blue-green deployment. So this uses two identical production environments.
Right.
One environment, serves live user traffic, while the other one just sits there and receives the new application version.
I always picture this like having a stunt double on a movie set. Like the blue environment is your main actor and the green environment is the stunt double.
That is a great way to look at it. But the crucial mechanism here isn't physical cables being unplugged.
Right, it's virtually managed.
Exactly. A network router or load balancer simply updates its routing rules. It points the incoming traffic from the blue IP addresses over to the green ones in mere milliseconds.
Wow, just like that. And if the new release crashes?
You just instantly reroute the traffic back to blue. No harm done.
So we've safely deployed. But what happens when traffic spikes? Question 2. When designing cloud-native applications, which property ensures that the application can easily scale horizontally by not storing session data on the local server?
Well, the correct answer is B. Statelessness means that an application does not store client session information locally on the server.
Meaning each request just stands on its own.
Precisely. Each request contains all the information needed for processing. And what's fascinating here is how removing the memory of past sessions actually improves system resilience.
Because the server doesn't remember who you are from your last click, right?
Exactly. Your browser has to send an authentication token with every single request.
Oh, I see.
Yeah, this means a load balancer can send your next click to literally any available server on the planet, making horizontal scaling totally effortless.
That makes perfect sense. But scaling servers is one thing. Scaling the data they use is another entirely. Question 3. In standard cloud architectures, which service type provides a distributed, durable, and scalable solution specifically for storing unstructured data like images and backups using buckets?
The correct answer is D. We're talking about object storage. It's a storage architecture designed for massive amounts of unstructured data.
Where data is stored as objects within buckets and access to their APIs, right?
Yeah, exactly.
Why buckets, though? I mean, why not just normal folders like on a regular hard drive?
Well, because traditional folder hierarchies eventually hit a performance wall when you have, millions of files.
Right. The system gets bogged down searching through the tree.
Exactly. Object storage uses a flat namespace instead. You just toss an object into a bucket, and the system hands you back a unique API URL.
So there's no complex file system bottleneck slowing down data retrieval.
Precisely. That flat structure is exactly how it scales infinitely.
Okay, infinite storage. Now, how do the individual pieces of our app talk to each other across different physical machines? Question 4. In modern container networking, which mechanism allows containers across different hosts to communicate seamlessly by creating a virtual network on top of an existing infrastructure?
The correct answer is C, an overlay network. This creates a virtual networking layer right on top of the existing physical network infrastructure.
Wait, so it's like a network inside of a network?
Exactly that. Think of it like a secure, invisible tunnel. The physical routers only see encrypted packets moving between servers. But inside those packets, the containers think they're plugged into the exact same local switch.
Which completely decouples your application from the physical hardware limits.
You hit the nail on the head.
Now, with all these separate containers and virtual networks, something has to keep track of the chaos. Question 5. Which component within the Kubernetes control plane is explicitly responsible for storing the authoritative state and configuration data of the entire cluster?
The correct answer is D, etc. It is the distributed key value data store used by Kubernetes to store the cluster's authoritative configuration and state information.
So what does this all mean? Is it basically the brain's memory bank?
Spot on. It acts as the ultimate source of truth for the whole system.
Because in a distributed system, you risk a split-brain scenario, right? Where two servers disagree on what's happening.
Exactly. So etc. uses strict consensus algorithms. If Kubernetes needs to know how many containers are supposed to be running versus what is actually running, there is only one indisputable record to check.
Which leads perfectly into how Kubernetes actually fixes those discrepancies. Question 6. In Kubernetes workload orchestration, which controller is best suited for deploying applications that must scale up or down dynamically while supporting rolling updates and rollbacks?
The correct answer is B, a deployment. This is a Kubernetes controller that manages stateless applications by maintaining the desired number of pod replicas.
So it's the engine that constantly compares reality against that etc. sorts of truth.
Exactly. If etc. says you need 5 pods and one crashes, the deployment controller automatically spins up a new one to replace it.
Constant self-healing. I love it. Now, how do we secure all of this? Question 7. To establish secure programmatic communication between distributed services and cloud platforms, which mechanism provides single sign-on capabilities using token-based authorization frameworks?
The correct answer is C. It's OAuth 2. This is an authorization framework that enables secure token-based access.
Right, so instead of sharing user credentials, applications just obtain access tokens.
Exactly. And if we connect this to the bigger picture, OAuth 2 secures the modern distributed systems we just built in the previous questions.
Because sharing a mask or password is a massive security risk.
Huge risk. Instead, a service gets a temporary limited access token. It's like giving an employee a key card that only opens their specific office floor rather than the master key to the entire building.
We've just covered blue-green deployments, statelessness, object storage, overlay networks, etc. deployments, and OAuth 2 for the Linux 701-200 exam.